Okay, let's do another synthesis example. And this time, let's make this molecule, again an alcohol, from this alkene. It's a little bit more complicated. Okay, so let's go backwards. We know that these carbons, your benzene ring plus 1, 2 carbons are going to be a piece. So there's our benzene ring. There's 1, 2. So this is kind of the carbon that apparently is getting attached later on. So let's use this carbon as our nucleophile. And that would have attacked our carbonyl to make our tetrahedral intermediate that formed our alcohol. So there's our tetrahedral intermediate. And of course that would react with water to form our final product. And we form this tetrahedral intermediate by attacking a carbonyl with some kind of organometallic nucleophilic species. And if we really want to get picky, we can go backwards on this particular group and say, yeah, we made this from some halide plus magnesium. That's how we made that reagent. We could have made a Grignard. We could have made an organolithium. Now let's focus on this piece. And notice that we have to take this backwards to styrene. Well, how can we make this carbonyl? We could have made that carbonyl from an alcohol. How do you make alcohols into carbonyls? Well, you do something like a PCC oxidation or a Swern oxidation. Now, how can we take this alcohol backwards and think of it as having come from this alkene? Well, that's actually a hydration of an alkene. We're going to hydrate this alkene, and this goes back to our electrophilic addition reactions. And in particular, we need the anti-Markovnikov alcohol. How do we get the anti-Markovnikov alcohol from an alkene? Well, we treat it with a combination of first BH3 and then sodium hydroxide, hydrogen peroxide, and water. And that will get us to our alcohol. So here we've completely dissected this molecule from the complexity of the product back to our required starting material. And we can string these together. Start with our alkene, treat with BH3. It's our hydroboration. And sodium hydroxide, hydrogen peroxide. That gives us our alcohol. We can then oxidize this alcohol. Let's see, in the sheet we said, or in the solution we said PCC, so we'll use PCC. Could have also used a Swern. And now let's combine a couple steps. Let's go ahead and use pre-made methyl magnesium chloride, which is what these two reagents would combine to form. And then we'll treat that as a fifth step. We'll add water, and that will give us our alcohol. So there's a slightly more complex example of retrosynthesis to make an alcohol. In part, it's more complex because we had to recognize that we were going to do an oxidation of an alcohol in there. And then this anti-Markovnikov hydration was also a little bit tricky.